Friends, you can see that we are looking at a C++ program where we're trying to compare the structure facilities available with C++, as in with C, and the class that you can, and the classes that you can make in C++. So let's look at the structures first. Simple, just as you write it in C, you write it just like that in C++ also. So you have got this struct student record for holding a student's record. You've got char name 51. This is as you can see, it's a character array which is to be used as a string. Then you've got unsigned int roll, and you've got float CGPA. So this is all as you would do in C. The extra thing being that you can also include now a function inside the structure. This is not something that you could actually do in C. You could, however, in C, or as indeed in C++ also, you could include a function pointer which you could use to point to various functions of that same type. But this particular concept where you can write a function as part of the declaration of a student record type, this is new in C++ rather than in C. I mean, that is to say that when you migrate to C++, this is something new that you see. This is to extend its object-oriented features, that is C++'s object-oriented features of data encapsulation to the structures in C. Now, when you are using these various variables that you see inside structures, they're all pretty much public in nature. There are three qualifiers in case of C++: functions and variables residing inside structures and classes. That's public. It's really like a C structure, variables, rather a C structures variables visible everywhere. You can just access them using the member of operator. And private, which can only be accessed from within the scope of the structure or class. And protected, which can be used from within that structure or class, or it can be used from especially when it comes to a class, it can be inherited into another class and used there. While public and protected are inheritable and accessible to the children classes or the child classes. In case of our private variables, they are not accessible outside this particular class or structure at all. If you leave this bit and go into the class now, the main difference that you will encounter is the fact that whereas in case of structures, the default qualifier was public, in case of classes, the default qualifier is private. So this is a major difference. So that means that name cannot be accessed by using the member of operator. It has to be accessed by using a public function like this. So public makes the declarations that come after it as public, that is the integers or floats or characters or the functions that come after it, these are all declared public henceforth, because I'm using the keyword public here. So public unsigned int role and void class name, then I get the class name here. Float CGPA, that will also be public because it is coming after the use of public, so on and so forth. And then set name here, because you see name here is left alone. We are not using any other particular qualifier here, so it is nothing but private. So that means you cannot just access it from outside. Let's say that you make a class object, just like you do a structure object, you do a class object also. When you create a class object, and these are created as follows, as you do in case of C, that is exactly how you do here also. You see, start student record SR, this one here, start student record SR. This is as you do in C. Similarly, when it comes to a class, you do something like this. There, strec s1, this is the declaration of the class. Let me just put a small gap here so that you can see. So this is the strec class, which is this one, this class here. This has been instantiated, that means we have made an object of it here, whereas this is the structure object SR. Whereas we can do C in SR.name, where C in is the input stream object which we use to input variables of the keyboard to the particular place that you want it to go, for example in a variable or in a variable inside a structure or a class. We could do that with s1.role. S1 is a class object. We could do the same thing as we do with SR here. We can do it with S1 here, because out here S1 has been declared here. You can see S1 is declared, role has been declared as a public, this one here, role has been declared as a public variable, and that is exactly why we could easily do C in s1.role. We cannot, however, do C in s1.name. For example, if I want to change this here, I just want to do is C in s1 dot name. Let us see what happens, how the compiler behaves. Just remember that we have not used any qualifiers. Let us go back into strec class. We have not used any qualifiers for name, which actually implies that it is a private variable. That means it should not be accessible outside the class. But let's see if it is or not. See, s1.name, this is something I'm doing right now. Now if you want to run it, first I have to compile it obviously. See, immediately you got an error. What does it say? C in s1.name. Class strec has no member named s1.name. Okay, okay, so sorry, that was I beg your pardon, that's my mistake. So capital M. Now if I just run it, see, that's the thing. the error. So error is, it is private within this context. Okay, it is declared as private. So you can see this is the error. Actually, the previous one was my fault. I used a small n. As you know that names are always case sensitive. So I used a small n. That was my bad. We have capital name n. When I'm trying to use this, what is happening? I am seeing that I cannot do s1.name directly, as you can see here, particularly here, this particular place. As you can see that name 51 is private within this context, that is C in s1.name you cannot use. Why? Because it is a private variable to s1. S1 is the object of the class strect, and it is a private variable to s1, and as such what will happen is you cannot access it as if it was in case of a structure. This same thing we used here, sr.name. Let us just go up and see in student record. See, name is declared here, and in strect name is declared here. This is a class. Same declaration in case of strect appears here also, but in case of student record, the name of student record is easily reachable here. This one doesn't give you any errors, but this one is not reachable. Why? Because when you leave it alone, as I said, just to repeat myself, you leave it alone without any qualifiers, it becomes private in case of classes, but it stays as public in case of start student record. So that is exactly why you see we use something called an access function. So here this is the set name. What is the set name? So it's the same as here you have a get name. We don't have a set name because we can just use the dot operator. But since we cannot use the dot operator here, what we're doing is we are actually giving a set name. It's called a set method, and this is called a get method. The get and set method. So set name is setting the name in that particular object. Now how do we do that? So first of all, we actually ask the student to give the name, or ask the user to give the name, and then we do C in name. Now remember, we do not need to use an object context here, because obviously we are doing it within the class itself, that is within the object itself it is being done. So this name, this particular name that we are doing the C in is actually this one here. Okay. So we have whatever we are entering, this will go into name. Now this has to be released because obviously it's private, so you cannot access it using a dot operator. So we have to release somewhere, and this is how we release it. Basically we return. Now what we return is char star get name. We return name. Name, as you can imagine, I'm sure you will understand this. Name is obviously the name of the array, which is nothing but the reference to the starting element of the array. So it's a reference to the starting element of the array. And that's all very good. So how does that work out? Basically, the starting element of the array is returned using the character pointer here. The return type of character pointer here. Okay, this particular part. This one. Highlighting this. See? The part I've highlighted. Char star. That is the character pointer. So name is basically the reference to the starting address of a, or rather it contains the starting address, or it refers to the first element of the array of characters. So it is actually a character pointer, and that is what we are returning here. We are returning the address of the first element of the array. And immediately what is going to happen? Immediately what is going to happen is we are going to return effectively the first element of the array, and in which case that means the first character of the string, and in which case all the other strings, all the other characters of that particular string, in this case name, can be accessed by a simple bit of pointer arithmetic that the compiler does for us. We can do it ourselves also, as we shall see later when we are doing pointers again in C++. Just to remind you of pointers in C, more or less the same, but for now, so this is what we are going to do. So we are setting it and then we're getting the name also, and this is how we are accessing the private method. So in object-oriented programming parlance, there is something called data encapsulation. Data encapsulation means that you've got some attributes. What are attributes? These are attributes. This float CGPA, these are actually attributes. You see, these are attributes because, see, an object, it represents a particular entity. Like what? Like, for example, if you have the design of a car, that is actually as a class. When you follow the design in actually making a particular car, that is a car with a registration number, a proper car, a concrete implementation of the design, which you buy with money and which you ride for joy, for pleasure, or for work, or for whatever purpose, that is your car. So for example, we know that one of the most popular cars in India is the Maruti Swift. Now this Maruti Swift design is actually the class of cars called Maruti Swift, and each Maruti Swift each Maruti Swift car is actually an object of the design of Maruti Swift. Okay, so similarly here, this is actually the design of a particular user-defined data type, class strrec. This is a class of objects. What are these objects? These are strrec objects. Strrec is the name of the type, and the type is described as you describe in case of struct student record. Similarly, here, this is a class of objects, and the object description is as follows: that each of the object will contain a private string called name, and a public integer called roll, and a public function called class name, and a public variable called float CGPA, and two public set name and get name methods for inputting the name and receiving the name, that is outputting the name. Well, outputting actually means cout, using cout or printf in C, cout in C++. So I'm not using the word outputting, I'm saying receiving. So you receive the name, then you can output it. So this is called data encapsulation. Attributes. Now, as I was saying, that objects are then this particular, we call them instances of the classes. So we call them that. It actually means the concrete representation or the concrete coming into being of a particular class. It's an object that has been created from a particular class, and that is there. Now you see, this object is like an entity. Just like a car is an entity, a human being is an entity. Similarly, an object is an entity. So, what would an object look like or feel like? That is given by the variables. Okay? Now look at it, for example. Let us say for a particular student record, the name is Akash Sen, roll number is say 1, and CGPA is say 9.5. This is a particular entity. What entity is it? It's an strec object representing Akash Sen. That is distinctly different to another very identically designed object for, say for example, there is a lady called, say, Khushi Singh. So you have Khushi Singh, role is 2, and so you got CGP of 9.1. So that is a different object, although that object again will have a name and a roll number, a CGPA, and all these 3 methods. Still it's a different object. And how will I differentiate one object from another? The answer is, if I look at the name is different. That means the value is different. If I look at the role, then the 2 roles are different. That is, the value is different. If I look at the CGPA, the 2 CGPAs are different. That means the values of the CGPAs are different. Even if the CGPAs are the same, let's say Khushi Singh has got 9.5 and Akash Sen has also got 9.5. In that case also, the roll numbers will be different and the names will be different. If at all anything, if there are 2 Khushi Singhs, both of them got 9.5, or 2 Akash Sens, both of them have got 9.5, still the roll number will actually be different. So the combination of these 3 variables will identify the record of Akash Sen, the one that we want, to Akash Sen, that the one we do not want, like that. So it will be distinguishable like this. So that means one object is distinguishable from another by its values, by its attributes. You see, let me give you philosophically an example from real life. 2 people study in the same class, gone in the same school, coming from the same type of family background. Say both of them have working parents, a teacher or doctor or engineer, whatever, middle class people, okay, well-to-do families, gone to the same school, studied in the same place. One turns out to be a really nice person, another turns out to be a really bad person. Why? Because of values. The nice person has got great values. The bad person has got very selfish values. So you see, similarly, here also, with these 2 objects, the values being different will distinguish one object from another. The value of the string name, the value of the roll number, the value of the CGPA, either taken one after the other or taken together, whichever one it is, the values being different will differentiate one object from another. This is the real life modeling possible only using a paradigm like object-oriented programming. Now, this is called data encapsulation. That now this so the attributes, that's why they called, you see, that's why they call attributes. As you say, the attributes of so and so person, the attributes of so and so people, the attributes of so and so TV, attributes of so and so. So similarly, these objects have these attributes that define them. So the attributes, name, roll number, CGPA, these are there, and the functions that handle them. In this case, you see, name, get name, set name, etc. These are bunched together as one inside a class, and that is exactly why we call this data encapsulation. Data encapsulation, as if data and functions are put inside one capsule together, just like a medicine. And the other attribute that I talked about, that I just showed you, that if you want to make it want to access a private variable, it won't allow you to access the private variable from outside the class. This is called data hiding. That means to control who accesses the data and how the data are accessed, the qualifiers are used to see if they are public or if they are protected or if they are private. When we do inheritance, we'll know more about this. But private variables cannot be accessed from outside the class. Public variables can be. We'll talk about protected variables later on in due time. So what happens here? A very simple thing, that data is hidden from view. Okay, just as you have seen, data is hidden from view and is only accessed by the proper function which knows how to access it, which has the permission to access it, and it is a member of the same class to which the attribute belongs. This is called data hiding and data. So we had data encapsulation and now we have data hiding. The third most important thing that we will cover in due course of time is inheritance, where you will see that the encapsulated data with proper levels of hiding, if you like, can be passed from one class to another, so that one object may have desirable features of another object, just like a parent and a child. But we'll see that in due time. So this is the construct of a class. The class also has something called constructors. This will be the object for next lecture. But that means to say that rather there will be the subject of a next lecture. But for now, let us now run this program and see what we have. So now it is asking for some values. Okay. So what are these values? These are values for the student record. So we have to give it name. Okay, and then run it. So let's give it a name, Akash. Okay, so you have asked it to print it 2 times, you see. First of all, cout SR.name, and then once again in cout SR.getName. So we can access SR.name directly, but then accessing SR.name, I'm using endl. Now as you know that this \n is a new line. It prints a new line. It takes a cursor to the new line, but it does not clear the buffer. This one here, endl, is used to not only clear to go to the new line, but also clear the buffer. It's better to use endl instead of \n. It is always better to use endl. So getName is that struct student records getName that we're using here, not the strx getName. It is the struct student record getName. Okay. See, this is the SR is the object of struct student record. This is the getName that you find in struct student record. When you run it, okay, you enter it, Akash comes out first of all as a cout, and secondly as the return from getName. Okay, now what does it want? It now wants roll, and then it will want CGPA. Okay, so running it, once again we'll start with Akash. Obviously you have to go for that. Then it wants the roll, let's say it's 1. Then it wants the CGPA, let's say it's 9.5. There. Now we are into strec. We are now into the object of the class strec. Please enter the student's name. So Khushi. Okay, C. So we have Khushi printed out. This is a result of calling the getName of the strec object S1 here. this one here. We set the name. First of all, this class name gives us the class name, which is strec. We call set name. So it asks, see set name, look at the set name method function, that is, please enter the student's name. This is what it is. Beg your pardon. That's one thing. So yeah, something went wrong somewhere. I've mismanaged it somehow. Okay, so set name. So this set name here, you saw the running of it. So the set name here, please enter the student's name, see in name, and get name, return that name. So that is exactly what was happening there. Let's see what's happening here. So s1.name in we're looking at line number 59. So we'll probably, yes, we have, this one was commented out, the comments there. So if I give the name Akash, actually what had happened was there was a comment and I had accidentally removed the comment. That was there to show you why s1.name would not work. Okay, so this is, see, now we are trying to give it s1.setName. We are inside s1.setName. Please enter the student's name. It says Khushi. I give it Khushi, goes into s1.name, and then the s1.getName is called, the last, and Khushi is printed out. So friends, I hope you now realize how C++ works. This is a basic program. We'll build upon this as we go around. And obviously, you can imagine how structures and classes are different in C++. Mainly, that's, apart from everything else, structures have default public variables, while in C++ classes, the default is private. And classes are obviously much stronger entities than our structures. So with this, we end these discussions. Come back soon with, we'll come back soon with more on these classes and their constituent functions.